Today, I'm going to talk about some of the challenges that analytics engineers face in K-12 education and how we are leveraging community and open source tooling such as Dagster to solve those challenges. The responsibilities of an analytics engineer more broadly are also true of those in K-12 education. However, we do have our own K-12 specific goals. We do this work because our goal is to provide a complete view of a student. There are many things we want to know about students to ensure that they are on a path to success. We want to know who they are. We want to know their grade level, their race, their ethnicity, if they have a learning disability, and we want to know things like their attendance and things like their grades. And so let's look at the challenge that we face with data in K-12. So our disparate data is spread across many different systems, and that may sound super familiar and similar to your environment. Student data, attendance, grades, assessment, etc. It's housed in various systems, and unfortunately, Fivetran and Stitch just don't have connectors for us. Assuming that the vendor has a method for us to get data out from their system, that method is going to vary from vendor to vendor. So hopefully they have an API that's wonderful, but sometimes they have just SFTP drops. Sometimes they can email us a file on a schedule. Sometimes we have to log into their system and we have to download an extract of our student data. Or sometimes we don't get anything, and we have to engage in conversations with that vendor to see what's possible in terms of what can be put on their roadmap. Now, once we get the data out, well, similar data can be represented very differently. So on the left column, we have the student last name. We can call that student last name, but other vendors may call that last name. Some may call it family name and others last surname. And so that's just a look at kind of how disparate the data can be in terms of location, access, and what it actually looks like. And end of the day, people, our customers who are our educators, our school leaders, our students, our families, they just want the insight, right? And so they just want to know for the specific education organization. So think school district, think state, think charter management organization. They just want to know, what is their student attrition? How many students have left since the start of the school year? How many students are chronically absent, and who are they? Which students have a learning disability or an IEP is what we call it. And when you look at data, how can you cut that data by the different things? Look at things like attendance by race and ethnicity or by gender, et cetera, et cetera. And so let's look at how we're solving that in K-12. So the solution is being built through a community led by the EdFi Alliance. It's a 501c3 nonprofit, and the EdFi Alliance has committed to publishing all technology open source under an Apache license. The community works on a set of rules for collecting and organizing student data, and those rules manifest themselves in the EdFi data standard. The EdFi data standard is a set of RESTful APIs. And so the screenshot on the right may look familiar to you. This is just a Swagger document, but the power is that all of the endpoints have been decided by the community, and then we can go to the vendors and we can say, this is how we collect student data. We use these endpoints, the endpoints have these payloads, and it uses this nomenclature. And so it just sets the tone for the conversation. So we are all talking similarly, and our conversations themselves can be interoperable. So let's look at this diagram. So here's where the collection of disparate operational data gets really cool. Through either state mandates, philanthropic funding, or just good intentions, the vendors create an EdFi API client that takes their operational data and sends it back to customers via the customer's EdFi API. Said another way, it is the responsibility of the vendor to submit data back to the education organization. The education organization does not pull data from the source systems. They stand up their own EdFi API that's following that data standard, and then they receive the data back to them. And we have had a lot of success with states creating mandates. So for example, if you do business in the state of Texas, in the state of Arizona, Wisconsin, you can only do business in the state if you maintain an EdFi integration. So EdFi eases the process for education organizations to receive their operational data via a common data standard and model. This solves the operational piece, but does not touch on analytics. And that is where Dagster comes in. Once an education organization has their disparate operational data in a common operational data store, or ODS, Dagster is used to pull that data back out of the EdFi API, store it in a data lake, and materialize it in BigQuery in nice, tidy data marks. Here's what that looks like, just a level deeper. And so in this example, I am using Google Cloud Storage for my data lake, and I am querying that data lake via BigQuery through what are called external tables, and I'm using dbt, which we all know, to manage my SQL transformation work. So let's look at just a few kind of screens so I can walk you through this and help you be able to put your finger on it. So here's that Swagger document I shared. And so the Dagster graph today looks a little something like this. So it's your kind of traditional ELT job where you've got this central extract and load, but I've got to run some ops at the top because the EdFi API has this idea of change versions. And what that allows me to do is pull deltas. So I can pull all data for an education organization on the first run, and then on subsequent runs, I can just pull what has been changed or deleted. So I run those ops first, and then I move into the extract and load. And this is all one single op today because I'm using, as I'm fetching from the API, I'm using a generator to be able to yield results back and upload to the data lake to reduce the memory footprint. But it's definitely like a to-do on my side to be able to split that out if I can, and will likely reach out to all of you on Slack for some thought partnership at some point. And then the final op there is running the EdFi models. Now, something that Sandy said earlier in this meeting really caught my ear around being able to mix assets and ops. That's going to be super powerful because in this example, I'm running a bunch of ops to be able to produce an initial asset to then produce additional assets via dbt tooling. And that's where, if you haven't checked out software-defined assets, I really recommend it because this graph is hiding the dbt models or those assets. And this is what software-defined assets allows you to do, is it allows you to blow up your dbt files to be able to visualize that inside of Dagster. And so I have things such as this facts table down here, and I can see the things, the dependencies, and the things that have to be run upstream to be able to get there. And I can start to see, well, what's being done in Python, what's being done in dbt. So I just wanted to show that visual. This is what that data lake looks like. So I'm using Hive partitioning inside of Google Cloud Storage to be able to have my various API resources, and then to be able to have my data segmented by school year. And if you've used Hive partitioning, you know this equal sign. And to be able to run Dagster jobs where they always just extract and load into the data lake. Nothing gets deleted, everything gets preserved, and everything gets put there as just raw JSON. And then in BigQuery, I'm able to have these tables where they are external tables. So if I look under details, It's an external table. It's pointing to my sandbox environment that is my bucket that has my raw JSON and is using Hive partitioning. And so I can build DBT models that are using SQL to query this external table, which is really just my portal into my data lake. So I can create my various data marts. So things like grades, fact table, my DIMs, and what have you. So that's just a little look at that piece. And then a few other things that I wanted to mention. So this work can get pretty complex. And so let's talk about community to see how it's taking place. So as a K12 analytics engineer, I maintain open source repositories that implement everything that you've seen here. You can access it at k12analyticsengineering.dev. I also maintain a Google Sheet that lays out the learning journey for a person to become an analytics engineer in the K12 space. Finally, I also provide pro bono mentorship and support to any education organization that wants to tackle this work to help their students. And then the resources will be also turning into a publicly accessible free online bootcamp that will run in cohorts where people can consume it. And they will walk through a full implementation, learn how to do it themselves, have the community for support. Again, all free, publicly accessible. One more thing before we move into questions. So there are times when a vendor does not build an EdFi API client to send data back to an education organization. There we leverage Dagster as well. For example, I maintain an open source repo that extracts data from the Google Forms API and submits that data to the EdFi API via their surveys endpoint. And so that's another part, is when the work just gets even more complex, is looking to the community to solve things together and to share those resources so that we can all benefit, because we all have the same goal, which is bring that data together to provide insights back to our educators so that they know where and how to help students. That's a look at K12. I will turn to any questions that people have.